Okay guys, continuing on with the 8.1 notes, we've got our first word problem. So here we are given two angles and the included side. So see how it is ASA. The side is going to be sandwiched in between the two angles that we are given. So a pole tilts toward the sun at an 8-degree angle from the vertical, and it casts a 22-foot shadow. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. How tall is the pole? So the figure is on page 563 in the book. I would recommend trying to draw the picture. It's really good for you to try to imagine what these look like. But if you're really struggling, the picture is provided for you in the book. So we've got a pole tilting at an angle. So it's not vertical, it's tilting. And so here's the ground. So say this is vertical right here. So that's your vertical angle. Okay. We're obviously going to be making a triangle here. An awesome triangle. This would be your angle of elevation, which would be 43 degrees. Let's just call this angle A. Okay, so let's call this angle C. So this would be angle B. If it tilts toward the sun, let's just say this is the sun right here. At an 8-degree angle, this would be our 8-degree angle. The angle of elevation from the tip of the shadow to the top of the pole, we got that, casts a 22-foot shadow. So the shadow is going to be right here from B to A. So that's going to be side C. So side C is going to be 22 feet. So we're going to be casting a 22-foot shadow. Now, we know angle B. Now, this is getting really messy, you guys. I'm really sorry. But we know angle B, since we know that it's 8 degrees plus the vertical, we know that this angle is 98 degrees, okay? So we know that angle B is 98 degrees. Angle A is 43 degrees. And C is 22 feet. Okay, so we need to find angle C, side B. Well, we don't even need side B. What we need is side A because it's a word problem, okay? So we need to know how tall is the pole. Now, to get how tall the pole is, we're going to need to use law of sines. So remember, A over sine A equals B over sine B equals C over sine C. Now let's think about it. We know we're going to have to use A over sine A because that's where our unknown is. Our unknown is A. We have to use A over sine A. Which one of these two are we going to use? We already know sine B, but we don't know side B. We know side C, but we don't know sine C. So we need to think about it, which one's going to be easier for us to find out. And I really hope that you said our angle C is going to be easier for us to find than side B, because it really is. There's really no way for us to find side B unless we use law of sines in another whole problem. So we're going to use the fact that all three angles in a triangle add up to 180 to find angle C. And then we're going to use law of sines to find side A. So we can easily say that 180 minus 43 plus 98 is equal to 39 degrees. So angle C is 39 degrees. So we've got A over sine 43 degrees equals 22 feet over sine 39 degrees. So we multiply both sides by sine 43 degrees. So we get A equals sine 43 degrees times 22 over sine 39 degrees. So again, I usually type in the fraction first, hit enter, then type in sine 43 degrees, hit enter, and you get that A is 23.84, and it is in feet. So the pole is 23.84 feet tall. Okay, next we're trying to find the height of the tree shown on figure 8.3 on page 563. So in that figure, we have a tree. I'm going to make the tree green. And it seems to be leaning a little bit. And the reason I know it's leaning is because the ground is at a 96-degree angle, it says. And then we've got this triangle going on. This says it's 22.5 degrees. It says that this piece of horizon is 30 meters. And we want to find the height of the tree. Okay? So I really hope that you guys pause me and try this. So you might want to relabel this as A, B, and C instead of this being H, and that's totally fine. I don't think that's a bad idea, okay? If this is A, this would make this A. This is B, this would make this B, and this is C, and this would make this angle C. We would have C over sine C. We would have to use B over sine B. So first we need to find angle B by taking 180 minus 96 plus 22.5. So we get 61.17 degrees. Oh wait, hold on guys. I'm so sorry, I messed this up. This is not 22.5 degrees. This is 22 degrees 50 seconds. So this 22 degrees 50 minutes, my bad. This is from chapter 6, remember? Minutes, degrees, minutes, seconds. When you have degrees, minutes, seconds, minutes, we put over 60. And we add. So this ends up being you would do this on your calculator. And this ends up being about 22, not 20. I'm just messing up all over the place. This ends up being 22.83 degrees. Why didn't anyone say anything? Oh, yeah. So 180 minus 96 plus 22.83 degrees. So we get that angle B is about 61.17 degrees. So we've got C over sine C. So sine 22.83 degrees equals 30 over sine 61.17 degrees. So we've got C equals sine 22.83 times 30 over sine 61.17. Remember, make sure that your calculator is in degree mode. So this tree is about 13.29 meters tall. So in the next video, we're going to talk about the ambiguous case.